All right, so we are on Chapter 2, Section 5, which is Learning Plan 1.7, Linear Inequalities in One Variable. So linear means they're going to be like x to the first power, 3x plus 5, and then since it's an inequality, will be something like less than 7. Only one variable. We're going to solve them using addition, multiplication. We're going to see 3-part inequalities, and then we're going to have some applications. So if you notice, a little review, open parentheses means that it's less than or greater than. Close or brackets are equal to. So you can see the different areas that we've got. And note, if it ends at infinity, you've got that open parentheses. Okay, so bracket, the difference between parentheses and bracket is the difference between a greater than sign and a greater than or equal to sign. All right, so an inequality is anything except that. So it'd be not equal to, greater than or equal to, less than or equal to. Any of those would be inequalities. One variable, here's the one variable. Remember, A, B, and C are real numbers. Okay, so we want all the numbers that make the inequality true. We do it by making equivalent inequalities. So we can do it using the addition property, which says you can add the same number to both sides, just like we had in equalities. So here we have an inequality. Let's solve it by adding 5 to both sides, and we get k is greater than 6. Now, we can use the interval notation, which would be parentheses, because it's not equal to 6, comma, infinity, close parentheses, or we could have 0, 6, open parentheses here, going this direction, like that. Okay, so you do this one. Okay, a plus 4 is less than negative 8. Subtract 4 from each side. A is less than negative 12. There it is, negative 12 to infinity. Notice the parentheses rather than the bracket because it's less than, not equal to. Okay. Sometimes we'll have variables on both sides. I always get it so that the variable is on the side on the left. So we're going to subtract 4x from both sides. And then let's subtract 3 from both sides. And the 4x's cancel and the 3's cancel. So we have 5x minus 4x is x is greater than or equal to negative 1 minus 3 more is negative 4. Interval notation is negative infinity, comma, negative 4, bracket, because it's equal to. We would put it on a number line. Here's 0, here's negative 4, bracket going this direction. All right, so you do this one. $13y plus 6 is less than or equal to 12y plus 16. Subtract 12y from both sides. Subtract 6 from both sides. The 12y's cancel, the 6's cancel. So you have y is less than or equal to 10. And it's a bracket. Here we go, right here. Less than 10. Okay. Now, sometimes we have to solve it using the multiplication property, and as long as we're multiplying by a positive number, the sign doesn't change. If we multiply by a negative number, notice we change the direction of the sign. Why does that happen? Well, I suppose I could show you. It goes something like this. We know that 4 is less than 5. If we multiply both of them by -1, we have -4 and -5. Notice -4 is greater than -5. So whenever you multiply by a negative number, you have to switch the sign. In this case, we're multiplying by a positive number, so we don't have to switch the sign. And we have m is less than or equal to -25. Here's 0. Here's -25. Notice it's going to be a bracket. Less than or equal to, parentheses, -infinity, comma, -25, bracket is our notation, and then our graph. Okay? Now, this time we're going to divide by a -9 to get the m all alone. When we do, we get m and 9, but we switch the sense, so m is greater than 9. Here's 0, here's 9, parentheses, this direction, to infinity, parentheses, 9, comma, infinity, close parentheses. So make sure when you have multiplying or dividing by a negative number, you change the sense. So first of all, to solve linear inequalities, we simplify them. We isolate the variables on one side, and then we solve it. Okay, now sometimes we'll have the distributive property. Multiply the 6 out, we get 6x minus 6 plus 3x is greater than or equal to -x minus 3x minus 6, right? That's the problem that people sometimes have. Combine these two as 9x minus 6 is greater than or equal to -4x minus 6. Looks like we can add 4x to both sides and add 6 to both sides, and we get 5x is greater than or equal to 0. Divide both sides by 5. X is greater than or equal to 0. On our number line here is 0, bracket towards the right, bracket 0, comma, infinity, close parentheses. Okay. You do this one. Alright, we've got -8x minus 20, right? Negative times positive is -20, is less than -10x minus 6. Let's add 10x to both sides. And let's add 20 to both sides. These cancel, so we get 2x is less than 14. Divide both sides by 2. Notice we don't have to change the sense. X is less than 7. Parentheses, -infinity, comma, 7, close parentheses. Or, right here, x is less than 7. All right. When we have fractions, remember, we can multiply everything by that common denominator. So this is going to be times 4. Notice here's another term. So this is going to be times 4. And this part's going to be times 4. 4 times 1/4 is just that thing. So we're left over there with x plus 3. 4 times 2 is 8. Is less than or equal to 3 times x plus 8. x and 3 and 8 is x plus 11 is less than or equal to 3x plus 24. Subtract 3x from both sides and subtract 11 from both sides. We get negative 2x is less than or equal to 15. Divide both sides by negative 2. We get x is greater than or equal to, switch the cents, right? Negative 7 or negative 15 halves. Okay. So here's 0, here's negative 15 halves. Bracket. X is greater than, I had that the wrong direction, didn't I? Greater than or equal to. When I switch the sense, it's greater than. So it'll be bracket negative 15 halves, comma, infinity, comma, parentheses. Okay.